Hey friends, today we will be solving this question. In this question, we will be seeing what will happen if the platform on which the body was moving starts moving itself. So we will be discussing how to solve this type of case. And so let's start without any delay. A plank of mass m1 with a uniform sphere of mass m2 placed on it rests on a smooth horizontal plane. A constant horizontal force is applied to the plank. With what acceleration will the plank and the center of the sphere move, provided there is no sliding between the plank and the sphere? Okay, so we are given that there is no sliding between the plank and the sphere, and here this is the plank. It is resting on a horizontal surface, and a sphere is resting on this plank, right? Its sphere's mass is I guess m2 and plank's mass is m1, right? And a force F is acting on the plank. So we have to find what is the what is the acceleration of both plank and the sphere. So as you can see, this plank will be moving with, let's say, acceleration a. Some problem occurred. Yeah. Okay. Yeah. This plank is moving with an acceleration a, and so the platform on which this sphere is resting is has started moving, right? So this sphere would also will have to move, otherwise there would be sliding between both of them. So automatically this sphere will also start moving with acceleration, let's say b. We are not sure if their acceleration would be same or not, but we will derive it mathematically if they are coming same or not, right? And yeah, so why will the if you go into the depth of this question, why will the sphere start moving with an acceleration b? It is due to the friction force that would be acting on the sphere, let's say F. As this plank is trying to move in the forward direction, there would be a friction force between the sphere and the plank that will try to resist the motion of the plank in the forward direction. So the friction force that would be acting on the plank would be in the backward direction, and the force that would be acting on the sphere would be in the forward direction, right? Yes. Due to this friction force, this sphere would be having an acceleration b. So as you can see that the friction force is also giving a torque, or also providing a torque about the center of this sphere, right? It is providing a torque about this point O. So automatically the sphere will start revolving or rotating with an angular acceleration of alpha, right? So we have assumed the variables. Now what is the next step? We have to write the equations and derive the accelerations of the plank and the sphere. So let's begin. So first equation would be the simple linear acceleration motion friction linear acceleration equation of the plank, right? So it would be like this: capital F minus friction force is equal to the mass of the plank into the acceleration of the plank. So this would be the first equation, and writing the linear acceleration equation on the sphere, what we can say is F, that is friction, is equal to mass of the sphere into acceleration of the sphere. This is the second equation, right? And where will we get this third equation? We will get it from the torque equation about point O. Right. So about point O, there's only one force, that is friction, that is creating a torque. So we will write it as F into, what would be the torque about the point O? It is equal to F into R, right? So F into r is equal to moment of inertia of this sphere, that is 2 by 5 mr square, as this is a solid sphere, m2 r square. 2 by 5 m2 r square, right? Yeah, into alpha. So from here I can write F equal to 2 by 5 m2 alpha r. So this is the third equation. Now fourth equation, from where we can get the fourth equation. So we can get the fourth equation from writing the no sliding condition, right? We are given that the sphere is not sliding on this plank. So the acceleration of this point and the point which is in contact with the plank on the plank would be same, right? So what we can say, the acceleration of each and every point on the plank is a. So the acceleration of the point on the sphere which is in contact with the plank would also be equal to a. So the point at the lowest position of this sphere is this point, and its acceleration is equal to the acceleration of the center of the sphere b plus the alpha. It is rotating in this direction, right? It is rotating in anti-clockwise direction. So alpha would it will add in the linear acceleration. So b plus alpha r, right? So a equal to b plus alpha r. This is our fourth equation. So from 1 and 2 equation, what we can write is f capital F is equal to m1a plus m2b, right? Now we have to solve these two to three equations, and we will get a final answer. So what we can do is, what we can do is we can equate 2 and 3 equations by writing this m2 be equal to 2 by 5 m2 alpha r. So m2 cancel, b equal to 2 by 5 alpha r. Now we can put the value of alpha r in the fourth equation, right? So a equal to b plus 5 by 2 b is equal to 7 by 2 b, right? Now we can simply put this value of a in this equation, right? So f is equal to m1a plus m2b, and b is equal to m1a plus, and b equal to b equal to 2 by 7 a. So from here we can write a is equal to f1. What is f1? Nothing. There is nothing called f1. So a equal to m1 plus 2 by 7 m2. This is the value of a, and similarly we can find the value of b. What is the value of b? Yeah, so b equal to 2 by 7a, right? So it is equal to f upon f into 2 by 7 m1 plus 2 by 7 m2. So it is f upon 2 by 7 m1, or let it be like this, right? Yeah, so this is our final answer. And if you have any doubt in this question or any other question that I have solved till now, then you can join my Telegram group. I have given the link of that in the description. And yeah, see you in another video. Okay.